Welcome to this new chapter where we will talk about pointers, a very important chapter that will show you the potential of C language because it is one of its most interesting properties. This chapter can be quite difficult to understand at the beginning, but by following well you can become very comfortable with it. So get ready. So what is a pointer? A pointer is just a variable that holds the address of another variable. If you remember, I said in the beginning of the course that each variable has an address in the memory. And the pointer is a variable where we can store the address of another variable, and by using it, we can access to the value of the pointed variable. We can even modify it if we want. Now let's move to the next video to learn how to declare and initialize a pointer. Welcome to this video where we will learn how to declare and initialize a pointer. Let's directly start with the syntax. First you have to know that a pointer has a data type, and this one follows the data type of the pointed variable. So if our pointer points to a variable of type int, its data type will also be of type int. So we said that we have the data type first. Then we put an asterisk. This asterisk is an operator that we've seen sometimes during this course. By this operator we can differentiate between a pointer and a simple variable. And after it we need the pointer name, and it follows the same rules as for a simple variable, and a semicolon obviously at the end. Let's do a simple example. For example, we want a pointer to a variable of type int. So we write int, then the asterisk, then the name, for example p, then the semicolon. We have these two other ways to put the asterisk, because we can also put it at the beginning of the name or join everything together. Now we have an int pointer, so it can hold the address of a variable of type int. But how can we do it? For example, let's declare an int variable named num, for example, and initialize to 5. And now we declare an int pointer for it. We can't initialize it like this, because we will get the value of num, but we want its address, not its value. And to get its address, we need to put the ampersand operator, the address operator, before the pointed variable, same as we did many times in this course. In call by reference, for example, we gave the address as a parameter if you remember, because the ampersand is a unary operator that returns its operand's address. This is why we use it. So we put an ampersand then the pointed variable. So by doing it in this example, now our pointer p holds the address of our variable num. And if we print the value stored in our pointer, this is what we get. It's just the address of num in memory. But it doesn't mean that we will always get this value necessarily, because we can't predict where the variable num will be stored. So it won't be stored at the same place every time. Let's do a second example. Let's declare a variable of type char, initialized to lowercase a, for example. Now if we want to point to this variable, we can create a pointer of type char, then the asterisk, then the pointer name, and now we can initialize it to the address of ch. So now our pointer p2 is pointing to ch. Imagine a pointer as an arrow to a certain memory location, and by using it we can access to the value of the pointed variable, and we can even modify it if we want. We'll learn how to do it in the next video. See you there. Welcome to this video where we will learn how to dereference a pointer. In other words, how to access to the value of the pointed variable. Let's take the example of the last video. We have the variable num of type int and initialized to 5. Then we created a pointer p that we initialized to the address of num. So now p holds the address of num, right? So if we print the value stored by our pointer and the address of num, they will be the same. But we want to get the value of the pointed variable, not the address. And for that, we have to put an asterisk like this, also called the dereference pointer. So if we print asterisk p, we get 5, which is the value stored in the stored address in the pointer. We can even get the address of the pointer itself, because as said earlier, the pointer has also an address in the memory, by using the ampersand before it, the address operator. And you can notice that it's different from the address of num, because they are two separate variables in the memory. In short, the pointer without any operator returns the address of the pointed variable, num in this case, and the pointer with the asterisk before it, the dereference operator, returns the value of the pointed variable. And the pointer with the ampersand before it, the address operator, returns the address of the pointer itself. To better understand, let's suppose we have our variable num with 5 as value and stored at the address 1000 in the memory. So at the address 1000, we find the value 5 as you can see. And we have our pointer p that points to num and stored at the address 2000 in the memory. So at the address 2000, we find the value 1000, which is the address of the pointed variable num. And now take some seconds to find the value returned by each one of these three elements. Pause the video and try to guess. Let's start. The value returned by the pointer without any operator is the address stored in it, which is 1000. The value returned by the pointer with the dereference operator before it is the value of the pointed variable, which is 5. The value returned by the pointer with the address operator before it is the address of the pointer itself, which is 2000. Take some seconds to analyze this because you really have to understand it before moving to another thing. Now that we've seen the dereference operator, you can see that we can access to the pointed variable and its value through our pointer. It's what we call dereferencing a pointer. And as said earlier, we can even modify it. For that, we just write the pointer name with the dereference operator before it, and we can assign a new value to it. For example, here we set the value 10 to num through our pointer, and if we print num before and after the instruction, you can see that its value changed for real. But what happens if we change the value stored in the pointer? The actual value stored in the pointer is the address of num. But you have to know that we can change it, for example, when we want to point to another variable. For example, we have another int variable named num with 15 as a value and stored in the address 1000 and 500s. At the beginning, we initialized our pointer to the address of num, which is 1000. But now, we can assign the address of num2 to our pointer if we want. So the value stored in it will be 1000 and 500s, because now it points to num2. And if we dereference it, we get the value of the actual pointed variable, which is 15. Let's analyze this code to understand better. We have our two variables num and num2 initialized to 5 and 15 respectively, and we have our pointer p initialized to the address of num. So now it points to num. So if we print the value of num, we get 5. Pause the video to take some seconds to understand if you want. You understood this? Nice, let's continue. Now we dereference the pointer to change the value of num and we set it to 10. So if we dereference our pointer, we get the new value of num. Let's continue. Now we change the value of our pointer itself and we set it to the address of num2. So now it points to num2. And if we dereference it, it returns the value of num2, which is 15, as you can see. And now we increment the value of num2 by dereferencing the pointer and using the increment operator. The parentheses are important here. And if we print the value of num2 now, we get 16, as you can see. Here is a little animation to understand because it's the most important video of the chapter. Here is a little animation to see what happened in each instruction. Watch the video again if you didn't understand because it's the most important video of the chapter. Now, do you remember that in the chapter about functions, in the pass by reference, we passed the address of the variable and the parameters was pointers and not simple variables. It means that there is a relation between pointers and functions. Let's see it in the next video. See you there. Welcome to this video where we will talk about the relation between pointers and functions. You have to know that a variable declared in a function can't be used in another function. It's what we call a local variable. And don't forget that the main is also a function. So if we declare a variable num, for example, in main, and we try to use it in another function, we will get an error, and vice versa. So to be able to use a variable in another function, we talked about parameters. And we have passing by value and passing by reference. In passing by value, we don't really give access to the variable directly. It will create a copy in the memory that holds the same value and will be deleted at the end of the function. This is why the original value can't be modified. So to be able to access to the original variable, we used the call by reference. And how did we do it? Instead of passing the variable itself, we passed its address. And as parameter, we used the pointer that will hold that passed address. And now that the pointer is holding the address of the variable declared in the main function, we can dereference it to access to the pointed variable. And now we can access to its value, and we can even modify it if we want. You really have to understand this concept because it's very important. In brief, in pass by reference, we pass the address as a pointer to be able to dereference it and access to the variable even if it's in another function. Let's see for example a function that adds 10 to a number. Here is what happens with call by value. We have the function and we call it from the main and we pass the value. So what's gonna happen here? The function parameter n will be created in another memory location and will hold the value passed as parameter, which is the value of our variable num. So you can see that instructions will be performed on the created parameter n and not num. Now the instruction is to add 10 to the function parameter. So n will change and will be increased by 10. As you can see, it became 15. But you can see that num didn't change, and at the end of the function n will be deleted from memory and num stays. Num will be deleted at the end of the main function. So we didn't meet our goal, which was to increase num by 10. This is why we're gonna use pass by reference. What's gonna happen? First, here is the function. The parameter now is a pointer. And why did we use a pointer? It's because while calling the function we will pass the address of num and not its value. So we need a pointer to store the passed address. Now that we called the function, the pointer will be created in another memory location and will hold the passed address, which is the address of num. So it will point to num. And inside the function we will dereference this new pointer to be able to access to the variable. So we can increase the value of num by 10 by writing this. So you can see at right that the value of num changed. And at the end of the function, the pointer will be deleted from the memory. I hope you understood the relation between pointers and functions. Watch the video again if you didn't understand. Now let's move to the next video to see the relation between pointers and arrays. See you there. Welcome to this video where we will see the relation between pointers and arrays. Let's quickly check the definition of an array again. An array is an indexed data structure used to store a collection of elements of the same data type. But what interests us the most is how is the array stored in the memory. For example, if we declare this array of 5 integers, we suppose that it's a 64-bit machine, so int occupies 4 bytes. What's gonna happen? If we suppose, for example, that the first element will be stored at the address 1000, the second element will be stored at the address 1004, because an int occupies 4 bytes. And the third element will be stored at the address 1008, and the fourth element at 1012, and the fifth one at 1016. But what is the relation with pointers? You have to know that r without brackets after it can act like a pointer, and it stores the address of the first element. Let's see what we get if we print the value of r and the address of the first element. They are the same. So, interesting thing we can do is to dereference r to access to the first element. Here is it. We printed the first element by dereferencing r. We can even modify it if we want. And we can do the same thing with the remaining elements. If you want to access to the second element which has the index 1, you dereference r plus 1. Don't forget the parentheses. In general, to access to the element with index I, we can do it by dereferencing r plus I. And if you remember, in functions we were passing arrays like this. We don't put the ampersand before r because, as said earlier, it's already an address, the address of the first element. This is why the function parameter is a pointer. It receives the address of the first element, then we can directly access to all elements. We can also set the array parameter like this, by the way. And we can also do the same process for strings, because a string is also an array, don't forget. But a string contains elements of type char, which occupy 1 byte in the memory, not 4 like int. So if we declare this string and the address of the first character is 1000, the string will be stored like this. And we can do the same manipulations using a pointer. And we can use pointers to point to an array. Same thing for strings. So this is the end of our video. In the next one we will see an interesting thing we can do with pointers, which is memory allocation. See you there. Welcome to this video where we will talk about memory allocation. If you remember, in arrays chapter, we created an array to hold the ages of 10 persons. But what if suddenly we needed more elements because new persons arrived, or at the opposite, some persons left? So we have unused elements that are occupying space uselessly. We can't fix it using the type of array we used because it's a static array. It means that once declared, we can't change its size. So if we declared it with 10 elements as the size, it's impossible to change it later. So we can't add or remove elements. This is why in this video we're gonna learn how to allocate memory dynamically. The main advantage of dynamic arrays is that we can change its size during execution as many times as we want. And to be able to do that, we will use what we call memory allocation. And to do so, we will use 4 stdlib functions: malloc, calloc, realloc, and free. Before diving into them, we have to know how much size an array occupies. If we have an array of 10 elements of type int, and each element occupies 4 bytes because it's of type int, and 10 multiplied by 4 is 40, so the array occupies 40 bytes. So in general, the size of an array is the number of elements multiplied by the size of each element depending on its data type. Now let's see the first function, which is malloc. This function takes one parameter, which is the size we want to allocate in memory, and returns a void pointer that points to that allocated memory location. A void pointer is a pointer that isn't related to any data type, so we can use malloc with any pointer type and without casting. What did we say about array size in memory? We said that it's the number of elements multiplied by the size of the data type, and this is exactly what we're gonna pass as parameter in malloc. The number of elements stored in the variable n, for example, multiplied by the size of the data type, and the result is assigned to our pointer. So for example, if we want to create an array of 5 floats, we write float pointer, then the array name, for example float array, and we initialize it to malloc5 multiplied by the size of float data type. The size of float is generally 4 bytes, so here we allocated 20 bytes for our array. Second function is calloc. It looks like the previous one. This one takes 2 parameters, the number of elements and the size of one element. So we don't do multiplication here because they are 2 separate parameters. And the main difference with malloc is that calloc initializes all the elements to 0. Before moving to realloc, you have to know that when we allocate memory, it's possible that the allocation fails, when there isn't enough space, for example. So after allocating, we have to check if the allocation is done successfully or not. So we set a condition. If the result is null, it means that it didn't allocate it successfully. So we can print it and we exit the program. We use exit 0 for Windows. Else the allocated is done successfully, so we can perform our instructions. Now we're gonna see the function that makes it possible to modify the size of our allocation during the execution. It's realloc function. This function takes 2 parameters, the allocated area and the new size. We will see its utility in an example in few seconds. Just the time to talk about the last function, which is free. This one will deallocate the space previously allocated by malloc, calloc or realloc. It takes one parameter, which is the allocated area, and it will deallocate it from memory. So the pointer will have the value null after it. And it's better to free every allocated space before ending the program, as we will see in this example. We will take the example of person's age, but this time we will use memory allocation and not just a simple static array. We will first create an array of 10 ages because we have 10 persons. Then during the execution, new persons will come, so we will increase the size of our array. Then some persons will leave, so we will reduce the size of our array. At the end, we free the allocated space. Let's start. In libraries, we need only stdio and stdlib, and we can define 10 as the initial number of persons. Before going to the main function, we can just create a function that will print all the ages like this. Now in main, we declare the variables. We have the number of new persons that will join, the number of persons who will leave, and the actual number of persons, which is initialized to the initial number of persons, which is 10. Then we declare the array using malloc. So we have an int pointer that receives the result of malloc, the number of persons, multiplied by the size of the int data type. And if the allocation failed, we exit directly. After it, we will fill the array by the age of each person. We use the do-while loop to verify that the input is positive. Now we print the ages. After it, new persons will join, so we ask the user for the number of new persons. We make sure that we have a positive value. Now we add the new persons to the number of persons. So for example, if there is 3 new persons, we will have 13 persons in total. And now comes the interesting part. We will increase the size. For that, we said that we use realloc. The first parameter is our allocated space, which is ages, and the second parameter is the new size, which is the number of persons multiplied by size of int, and we assign the result to ages. Note that the old element's values won't be removed, so we don't have to fill it again, we just fill the added elements. Then we check if reallocation is made successfully or not. After it, we get ages of the added persons. For that, we scan the initial numbers persons plus I, because we want to scan the element at the index 10, at the index 11, and so on, not from the beginning. And we obviously make sure that the age is positive using a do-while loop. After it, we print the ages again to see that the array changed. After it, we ask for how many people left. We make sure that it's a positive number, and that it doesn't exceed the actual number of persons. Then we subtract it from the actual number of persons and we realloc again. If the reallocation failed, we exit. Then we print the ages again to see that the array changed again. And at the end, we free the allocated memory, then the program ends. And here is an output example. I hope you understood these 4 memory allocation functions and see you in the next video. Before ending this chapter, let's just see some key points about pointers. First, we said that a pointer is a variable that holds the address of another variable. Second thing is that a pointer, if we don't initialize it, it will generally be initialized at null. This is what we call a null pointer. It points to nothing. Third thing, the pointer data type generally follows the pointed variable data type. Key number 4, we can dereference a pointer to access to the pointed variable. But be careful, never dereference a null pointer. Always check that your pointer isn't null. Key number 5, a void pointer can point to any data type, but we have to use casting when we dereference it. Key number 6, we can have a double pointer, a pointer that holds the address of another pointer. For that we use double asterisk. For example, we can have a variable num stored at the address 1000, a simple pointer stored at the address 2000 and pointing to num, and a double pointer stored at the address 3000 and pointing to the first pointer. Now we can have access to num with 3 ways: by using num directly, by dereferencing p1 once, and by dereferencing p2 twice, with 2 asterisks like this. And you can see that we get the value of num in the 3 methods. Key number 7, understanding pointers will make you comfortable with functions, arrays, and strings. This is why you can watch this chapter again if you didn't understand, because it's the end of this chapter now. So see you in the next videos. So it's the end of our course. Congratulations, you made it to the end. I hope that you're now comfortable with programming fundamentals. I hope that you'll learn new things from this course. Keep practicing, keep building projects to become a better programmer every day. If you ever noticed something wrong in the course or that you want it to be added, you can send me a private message. The icons used in this course come from flaticons.com. It has a lot of beautiful icons, and the authors of the icons I used here are FreePic, Pixel Perfect, Smash Icons, Flat Icons, Vectors Market, Dinosoft Labs, and Surang. They have really nice icons. And for the GIFs, I found them on Giphy.com. So don't forget to put your honest review about the course and to share the course to other people if possible.